I've been a journeyman lineman for Central Missouri Power Cooperative for 11 years, and in that time I have personally de-energized over 400 circuits. I have cut feeds to condemned buildings, severed connections to delinquent accounts, and isolated storm-damaged transformers while standing in rain so heavy I couldn't see my own gloves. Every one of those jobs has one thing in common. When you open a disconnect, the load drops. The meter stops. The draw disappears from the system like it was never there. That is how electricity works. It does not negotiate. It does not remember. You open the path and the current dies. On March 11th of this year, the load management system at our Calvary District substation flagged an anomalous draw on a distribution feeder that services the industrial corridor along the Osage River bottoms in Hensley, Missouri. The draw was small, 9 kilowatts. Steady, no cycling. In a residential context, that's a house running its furnace and a few lights. In an industrial context, it's almost nothing. But the feeder it appeared on feeder 7, Calvary Sub had been carrying a stable load profile for over 6 years. Our system notices when a new 9 kilowatt customer appears on a line that hasn't added a meter since 2019. It flags it. It generates a ticket. And that ticket lands on a desk. That desk belonged to my crew lead, Dale Presswood, and Dale handed it to me on a Wednesday morning because I was already scheduled for a service verification run through the Osage corridor that week. The ticket said the draw was pulling from a lateral tap near River Mile Marker 4, West Bank. The account code attached to it was one I'd never seen before. Most of our commercial accounts in Hensley start with a 3 or a 4. This one started with 09. Which Dale said was a legacy municipal prefix, something the city of Hensley used before the cooperative took over their infrastructure in the early 90s. I asked Dale what the account was registered to. He checked the system and read it to me off the screen. Hensley Municipal Pump Station, 14, River Road West, no building number. Status, disconnected. Disconnection date, November 3rd, 1987. A facility that had been electrically dead for 37 years was drawing 9 kilowatts from our grid. Dale assumed it was a metering error, a ghost in the load management software, or a CT ratio mismatch somewhere in the substation that was misattributing load from a nearby customer. He told me to drive out there, verify the tap was still physically disconnected, and close the ticket. Standard work, 2 hours tops. I drove out to the Osage corridor that afternoon. River Road West is a crumbling 2-lane that follows the river bluffs south of Hensley proper, running past old grain elevators, a closed fertilizer depot, and about a mile of overgrown lots, where light industry used to operate before the river flooded in '93, and most of the businesses never came back. The cooperative still maintains the primary feeder along that road because there are a handful of active accounts, a boat storage facility, a gravel company, and a water district pump house near the bridge. But most of the lateral taps along the corridor are dead. They've been dead since before I started. I found the tap for pump station 14 about a quarter mile past the gravel yard, where a short spur of wooden poles cuts west from the main line toward the river. There were 3 poles still standing, though the cross arms on the last one had rotted and the conductor was hanging slack. The vegetation was so thick I had to leave the truck on River Road and walk in along what used to be a gravel access drive. It took me 10 minutes to reach the end of the spur. The disconnect was still there. It was old S&C fuse cutout mounted on the last standing pole, and it was open. I could see from 20 feet away that the fuse barrel was hanging at a down angle, exactly the way it should look when a circuit is de-energized. No connection, no path for current. Whatever the load management system thought it was seeing, it wasn't coming through this tap. I marked the ticket as verified, disconnected, took 2 photos for the file, and started walking back to the truck. Then I stopped, because I realized I hadn't actually looked at the pump station itself. The vegetation was so dense past the last pole that I hadn't even tried. But I was already out there, and I had the time. And there's a part of my brain, the part that keeps me employed, that doesn't like leaving a site without seeing the whole picture. I pushed through about 40 feet of scrub willow and found it. Pump Station 14 was a concrete block building, maybe 30 by 50 feet, with a flat roof and no windows. The walls were poured in sections I could see the form lines, and the whole structure had settled slightly toward the riverside, giving it a faint lean that made it look like it was listening to the water. The entrance was a steel door on the north face, heavily rusted, with a Hensley municipal seal still visible under the corrosion. There was a steel conduit running up the east wall to a weatherhead near the roof line, the building's original electrical service entrance, and the conduit had been cut clean about 4 feet off the ground. Cut, not broken. Someone had taken a saw to it decades ago. Below the cut, the conduit just ended in open air. Above the cut, it ran up to the weatherhead and presumably down into the building's internal panel, but there was no wire inside it. The conductors had been pulled. This building had no electrical connection to anything. No overhead tap, no underground lateral, no generator, no solar panel, no battery system. I walked the entire perimeter. There was nothing. I put my hand on the steel door and felt a vibration. It was faint, not mechanical in the way a running motor vibrates, more like the hum you feel when you touch a transformer enclosure, that deep 60-cycle tremor that lingers in metal when current is flowing nearby. But there was no current flowing nearby. The nearest energized conductor was 300 feet away on the main road. I pulled my hand back and stood there for about 30 seconds, trying to convince myself it was traffic vibration from River Road, or maybe a barge engine on the river. But River Road was empty. The river was calm. And when I put my hand back on the door, the vibration was still there, and it was steady, and it was exactly 60 hertz. I've spent my career around energized equipment. I know what 60 hertz feels like in my bones. I called Dale from the truck and told him the tap was open and the building had no service connection, but that I'd felt something and I wanted to come back with a clamp meter to take some readings. Dale asked if I thought somebody had run a bootleg line into the building. It happens sometimes. People tapping the primary overhead to steal power for grow operations or Bitcoin mining. I said I didn't see how. The building was sealed, the conduit was cut, and there was no evidence of any new wiring. Dale said to write it up and he'd send a 2-man crew back if the load flag appeared again. It appeared again that night. Same feeder, same lateral code, same 9 kilowatts. And it appeared the next night, and the next. By Friday, Dale had escalated the ticket to our district engineer, a man named Vic Paletti, who ran a load analysis on feeder 7 and confirmed the draw was real. It wasn't a software artifact. It wasn't a CT error. Something on the 09-prefix lateral tap was pulling 9 kilowatts of power from the grid, steadily from approximately 11 p.m. to 4 a.m. every night, and then stopping. During daylight hours, the draw vanished. The feeder profile returned to normal. And then, at 11, it came back. Vic's first theory was induction. If the dead lateral conductors were still hanging close to the energized main feeder, you could theoretically get a small induced current enough to create a phantom load on the monitoring system without any actual galvanic connection. I told Vic the lateral conductors were hanging slack and at least 15 feet from the primary. He said that wasn't close enough for 9 kilowatts of induction. Not even close. His second theory was an underground fault path. Maybe the old lateral had a buried section that was still making contact with the primary through soil moisture, or a corroded ground grid. I told Vic there was no buried section that I could see. The lateral was all overhead. 3 poles, open air. He went quiet for a moment and then said he wanted to come out and look at it himself. We drove out together the following Monday morning, me and Vic and a second lineman named Corinne Brask. Corinne had been with the co-op for 3 years and was the sharpest troubleshooter on our crew, fast with the meter, calm in the bucket, and incapable of accepting an answer that didn't match the numbers. If there was a bootleg line or a buried tap, Corinne would find it. We spent 4 hours at the site. Vic checked every pole, every conductor, every ground rod. Corinne ran a Megger test on the lateral and confirmed the insulation was intact, no fault path to ground, no contact with the primary. I walked the perimeter of the building again, this time with a non-contact voltage detector, and got nothing on the walls, the door, the conduit stub, or the roof. The building read as completely dead. At 11 that morning, Vic called the Calvary substation and asked the operator to open the feeder 7 breaker for 10 minutes so we could do a deadline verification. With the entire feeder de-energized, there should be 0 voltage anywhere on the system. Every tap, every lateral, every transformer, every service drop, all dead. The operator opened the breaker. I confirmed the main line was de-energized with my own hot stick. Corinne put her clamp meter around the lateral conductor at the first pole. She read 2.3 amps. The line was dead. The breaker was open. There was no source of power anywhere on the feeder, and the conductor that ran toward pump station 14 was carrying 2.3 amps. Corinne checked her meter, checked her connections, and read it again. 2.3 amps. She moved to the second pole. 2.4 amps. The current was increasing as the conductor approached the building. Vic asked the substation operator to confirm the breaker was open. The operator confirmed. Vic asked if there was any possibility of backfeed from another feeder through a normally open tie switch. The operator checked and said no, all ties were open. All adjacent feeders were on separate buses. Feeder 7 was isolated. Corinne walked to the third pole, the one with the hanging cutout, and clamped the conductor on the building side of the open fuse. The cutout was physically open, the barrel was hanging down, the contact was broken, there was a visible air gap. No current should have been able to cross that gap. Her meter read 3.1 amps. Current was flowing through an open disconnect, through an air gap, into a building with no internal wiring, and the only source of electricity on the entire feeder had been switched off at the substation. Vic told us to pack up. He didn't explain why. He didn't speculate. He just said pack up, and we did, and nobody talked on the drive back. That afternoon, Vic sent an email to the district manager requesting a full engineering review of the Calvary Subfeeder 7 lateral infrastructure, and he CC'd the cooperative's general manager, which is something Vic has never done in the 8 years I've worked with him. The engineering review was scheduled for 2 weeks out. In the meantime, Vic asked me to monitor the load management flags on Feeder 7 each morning and log any anomalous draws. I did. Every night between 11 and 4, the 9-kilowatt draw appeared. Every morning it vanished. The pattern did not vary by a single minute. During the second week of monitoring, I pulled the cooperative's old records for the Hensley municipal system, the paper files that got boxed up when we absorbed the city's electrical infrastructure in 1993. It took me a day and a half to find the right boxes in our storage building, and another half day to sort through them, because they'd been packed by someone who apparently organized by mood rather than by logic. But I found what I was looking for: the original service record for Pump Station 14. The station was built in 1961 as part of a federal flood mitigation grant that funded a series of pump installations along the Osage River to handle stormwater drainage in the low-lying industrial areas south of Hensley. There were originally 16 stations. Most of them were decommissioned in the late 80s when the Army Corps of Engineers rebuilt the levee system, and the city decided the old pump network was redundant. Station 14 was disconnected on November 3, 1987, by a city electrician named Gerald Wynn, who signed the disconnect order and noted in the comments field, "All conductors pulled, service entrance cut, main breaker locked out and tagged, building sealed per city order 87-4402. Gerald Wynn was thorough. He didn't just open a switch, he physically removed the wiring. There was nothing left to carry current. The building was electrically lobotomized. I also found the pump specifications. Station 14 housed 2 vertical turbine pumps rated at 150 horsepower each, driven by 480-volt 3-phase motors. When both pumps were running at full capacity, the station's electrical demand was approximately 260 kilowatts. The station's job was to lift stormwater from a subsurface collection basin, essentially a concrete cistern built into the riverbank, and discharge it over the levee into the river during flood events. Between storms, the pumps sat idle. The station was designed to activate automatically when the water level in the collection basin reached a preset trigger depth and to shut off when the basin was empty. 260 kilowatts at full load. And something in that dead building was currently drawing 9 kilowatts is 3% of full capacity. It's not a pump running, it's not a motor turning, it's something smaller. Something like a control system, a logic board, a sensor array, monitoring equipment. The kind of low-power load that stays on all the time in an active pump station, watching the water level, waiting for the trigger signal. I kept that thought to myself, but I wrote it in my personal notes, and I underlined it twice. 9 kilowatts is a standby load. The engineering review happened on a Tuesday. Vic brought 2 engineers from the cooperative's main office in Jefferson City, a power quality specialist named Hao Chen and a protection engineer named Donna Kerrigan. I drove them out to the site. Corinne came along with the instrumentation. Hao set up a power quality analyzer on the lateral at the first pole. Donna inspected every inch of the conductor run, the poles, the cutout, and the building's exterior conduit. Corinne repeated her clamp meter readings at each pole. I stayed on the radio with the substation operator, ready to coordinate switching if needed. At Donna's request, we left the feeder energized this time. She wanted to see the system under normal conditions. We arrived at 9 in the morning, and the load management system showed 0 anomalous draw on the lateral as expected, since the draw only appeared at night. We set up the analyzer to record continuously and planned to leave it in place for 72 hours. While we waited for the instruments to collect data, Hao walked the riverbank below the pump station. He came back after 20 minutes and asked me to come look at something. I followed him down a muddy slope to the water's edge, where the concrete base of the pump station's discharge pipe was still visible, a 4-foot diameter opening in the levee face, sealed with a rusted flap gate. Hao pointed at the ground around the pipe. The soil was wet, not river splash wet saturated from below. There was water seeping up through cracks in the concrete apron around the discharge pipe, pooling in the low spots. It was 40 degrees outside, and there hadn't been rain in 6 days. The river was at normal pool. There was no reason for groundwater to be surfacing here. Hao knelt down and put his hand in one of the pools. He held it there for a moment and then looked up at me with an expression I hadn't seen on an engineer's face before. He said the water was warm, not hot, just warm, maybe 80 degrees. In March, in Missouri. I knelt down and confirmed it. The water was warm. It was also faintly turbid, with a mineral smell that reminded me of the deep wells out in the Ozark karst country. That limestone and iron tang you get from water that's been underground for a long time. Hao asked if there were any geothermal features in the area. I said, not that I knew of. He asked about hot water discharges from industrial processes upstream. I said the only industry still active on this stretch was the gravel company, and they don't use heated water. He didn't ask any more questions. He just took a sample in a plastic bottle and put it in his bag. That night, at 11:02 p.m., the power quality analyzer recorded the 9 kilowatt load appearing on the lateral. It also recorded something Vic's substation monitoring hadn't been detailed enough to catch. The load wasn't steady. It was stepping. It came on in 3 distinct stages. First a 2 kilowatt jump, then a pause of 40 seconds, then a 3 kilowatt addition, then a pause of 90 seconds, then the final 4 kilowatts, bringing the total to 9. The steps were clean. They looked like a sequenced startup, the kind of staged loading you see when a control system brings equipment online in a predetermined order to avoid inrush current. Something inside that building was waking up in stages, carefully, methodically, the way it had been designed to. The analyzer also captured the harmonic signature of the load. Hao reviewed it the next morning and told us the load was almost purely resistive in the first stage, consistent with heating elements or control circuits, and then shifted to a mildly inductive profile in the second and third stages, consistent with small motors or solenoid-operated valves. Not the big 150 horsepower pump motors. Something smaller. Something in the control infrastructure. Donna Kerrigan spent that morning on the phone with the cooperative's records department, trying to find as-built drawings for the pump station's electrical system. What she got instead was a callback from a retired city engineer named Pete Olvera, who had worked for Hensley Public Works from 1974 to 1998, and who, according to the records clerk, was the only person alive who might remember anything about those pump stations. Donna put him on speaker. Pete Olvera was 81 years old and perfectly lucid. He remembered Pump Station 14 clearly because it was, in his words, the problem child. He said the station had a history of activating when it shouldn't, running its pumps during dry weather, cycling valves when the collection basin was empty, energizing its control panel in the middle of the night for no reason the maintenance crew could identify. The city attributed it to faulty level sensors and replaced them twice, in 1978 and again in 1983. The false activations continued. I asked Pete if he had any idea what could cause a load to appear on a de-energized, physically disconnected circuit. He was quiet for a long time. Then he said something that made everyone in the truck stop moving. He said, "You're telling me the building is pulling power. I'm asking you, are you sure it's pulling? Because we never could figure out whether 14 was drawing current from the grid or whether the grid was drawing current from 14. Nobody responded immediately. Donna asked him to explain. Pete said that in 1986, the year before the station was disconnected, a power quality study commissioned by the city had found that the electrical characteristics of Station 14's load were anomalous. The study concluded that the station's power consumption did not match the expected profile for its installed equipment. The demand was too low for the pumps, but too structured for a fault. The study's author, an electrical consultant from Springfield, had recommended a full investigation of the station's subsurface components, including the collection basin and the intake system below the riverbank. The investigation never happened. The city defunded the pump station program the following year, and all 16 stations were decommissioned. Gerald Wynn cut the wires and sealed the doors, and that was the end of it. Donna asked Pete if he knew anything about the collection basin beneath Station 14, how deep it was, how it was constructed, what the intake piping looked like. Pete said the basin was standard across all 16 stations, a reinforced concrete cistern, approximately 12 feet in diameter and 20 feet deep, with a screened intake pipe that connected to a subsurface drainage network running along the riverbank. The drainage network collected stormwater from the low-lying areas and gravity-fed it into the basins, where the pumps would lift it over the levee. Then Pete said something else. He said Station 14's basin was deeper than the others. The original construction drawings showed 20 feet, same as the rest, but during a maintenance inspection in 1979, a city diver had measured the basin depth at Station 14 and recorded it as 31 feet, 11 feet deeper than the plans showed. The city attributed it to a surveying error in the original drawings and never followed up. Pete Olvera said one more thing before Donna thanked him and ended the call. He said that the city diver who measured the basin in 1979, a man named Arlo Suttner, had refused to go back in. Pete asked him why at the time, and Arlo said he couldn't explain it. He said the basin was the right shape, the right diameter, the right concrete. But at the bottom, below where the original floor should have been, the walls were smooth. Not formed concrete, not poured. Smooth like they had been worn down over a long time by something moving against them. Pete said, "Arlo told me it felt like standing inside a throat." The power quality analyzer recorded the 9-kilowatt load again that night, but this time it caught something new in the data. At 3:47 a.m., during the load's active period, there was a brief transient, a voltage spike lasting 11 milliseconds that propagated backward from the lateral tap onto the main feeder. Backward, away from the load, toward the substation. Howe flagged it in the morning and said it was consistent with a generator momentarily sinking to the grid before falling out of phase. There was no generator at Pump Station 14. There was no rotating equipment of any kind that we could account for. But for 11 milliseconds, something inside that building had pushed power out. When I got home that night, I sat in my truck in the parking lot of my apartment complex and thought about something that had been forming slowly in my mind over the previous week, but that I hadn't been willing to say out loud. The 9-kilowatt load appeared only at night. The warm water was seeping up from below the building. The basin was deeper than it should be. The control system, if that's what the load was sequencing itself on in stages, like a machine preparing for an operating cycle. And for 11 milliseconds, the system had reversed its flow and pushed energy outward. Pump Station 14 was not drawing power from the grid because it was broken or haunted or impossible. It was drawing power because it was getting ready. Something in that basin or below it was doing what the station was designed to monitor. The water was rising, and the system that had been built 60 years ago to respond to rising water was responding. The question I could not answer, the one that kept me in my truck until my hands were cold, was, where was the water coming from? The river was at normal pool. The groundwater table in the Osage bottoms was stable. There was no hydrological reason for water to be entering that basin from below, unless the basin was connected to something deeper than the drainage network, something the original builders hadn't known about, something the 11 extra feet of depth pointed toward. And whatever that something was, it was warm. It was pressurized enough to push water to the surface, and it had been there long enough to wear the concrete smooth. I went inside and didn't sleep. At 4:01 a.m., I checked the load management system on my phone. The 9-kilowatt draw dropped off the feeder at exactly 4 o'clock, same as every other night. But this time the load didn't drop to 0. It dropped to 1.4 kilowatts. A residual draw. Something that hadn't been there before. As if the system, whatever it was, had decided it no longer needed to fully shut down. As if it was keeping something running, even during the day. Watching, waiting, measuring a water level that nobody else could see. I reported the residual load to Vic first thing that morning. He pulled the overnight data from the analyzer and confirmed it. 1.4 kilowatts, steady, no cycling, persisting past the usual 4 a.m. cutoff and continuing into daylight hours. By the time I reached the office at 7:30, the draw was still there. It had never done that before. Vic called Howe and Donna back. Howe arrived from Jefferson City by noon. Donna conferenced in from her office. The four of us, Vic, Howe, Corinne, and I, drove back out to the site with additional instrumentation. A thermal imaging camera, a portable spectrum analyzer, and a hydrophone that Howe had borrowed from a friend at the State Geological Survey. Nobody said much on the drive. Corinne had printed the overnight load data and was studying the residual draw's harmonic profile in the passenger seat. She said it was almost perfectly sinusoidal clean, smooth, 60 hertz, no distortion. Power that clean doesn't come from failing equipment or fault paths. It comes from something operating exactly as intended. When we arrived, I noticed the seepage around the discharge pipe had increased. The wet area had expanded from a few square feet to a rough oval maybe 15 feet across. I could see the shimmer of water in the grass from the access drive. The air near the building had a different quality, not a smell exactly, but a density, like the humidity you feel standing near a cooling tower. It was 44 degrees outside. There should have been no humidity to speak of. Howe set up the thermal camera on a tripod facing the building's south wall. The image came up in shades of blue and purple cold concrete, cold soil, cold air, except for one area. Along the base of the east wall, near where the building's foundation met the ground, there was a band of yellow-green approximately 8 inches wide, running the entire length of the wall. Warm, measurably, visibly warm against the March air. Howe checked the temperature scale. The band was reading 91 degrees Fahrenheit. He moved the camera to the north wall. Same band. West wall. Same band. The entire foundation perimeter of Pump Station 14 was radiating heat from below. Something warm was in contact with the underside of the building's floor slab, heating the concrete from beneath and the thermal signature was uniform, not a hotspot, not a pipe leak, not a localized source. The entire footprint of the building was warm. Corinne had her clamp meter on the lateral conductor again. With the feeder energized and the load management system showing the 1.4 kilowatt residual, she read 0.6 amps at the first pole. At the second pole, 0.8 amps. At the third pole, past the open cutout, 1.1 amps. The same impossible pattern, current increasing as it approached a building with no wiring, flowing through an air gap that should have stopped it dead. Howe deployed the hydrophone. He drove a steel probe 2 feet into the saturated soil near the discharge pipe and connected it to the instrument. Hydrophones are designed to pick up sound transmitted through water. They're used for monitoring wells, detecting pipe leaks, and tracking subsurface water movement. What Howe expected to hear, he told us later, was the faint rush of groundwater moving through gravel or the ticking of expanding pipes. Normal geological noise. What came through the headphones was rhythmic. A low, repeated compression, not random, not continuous, but pulsed. Howe listened for about 30 seconds, adjusted the gain, and listened for another minute. Then he handed the headphones to me. I heard it. A slow, pressurized thudding, maybe once every 4 seconds. It sounded mechanical. It sounded like a pump. Not the big vertical turbine pumps rated for 150 horsepower, something smaller, something deeper, something that had the unmistakable cadence of a reciprocating machine moving fluid through a closed system. The sound was coming from below the building, well below. Howe estimated the source depth at 40 to 60 feet based on the signal attenuation, but he said the geology of the river bottoms, layers of alluvial clay over fractured limestone, made precise depth estimates unreliable. Vic stood very still while Howe explained this. Then he asked the question that all of us had been circling for a week. He asked it plainly, without drama. Is there any known mechanical equipment below this building that could still be operating? I told him no. The construction records showed the building slab, the collection basin directly beneath it, and the intake piping connecting the basin to the subsurface drainage network. The basin was the deepest component, 20 feet per the drawings, 31 feet per Arlo Suttner's 1979 measurement. Below that, there should be nothing but clay and limestone and whatever the Osage River had deposited over the last 10,000 years. Vic said, then either there's equipment down there that isn't on the drawings, or what we're hearing isn't equipment. We spent another hour at the site. Howe took hydrophone readings at 4 locations around the building perimeter. The rhythmic sound was present at all 4 points, consistent in frequency and amplitude, suggesting a single source located centrally beneath the structure. He also noted that the pulse rate wasn't perfectly steady. It was drifting very slowly, about 1 beat per minute faster than when he'd first started listening, as if whatever was producing it was gradually accelerating. Before we left, I walked down to the discharge pipe one more time. The flap gate, the rusted steel valve that sealed the 4-foot pipe opening in the levee face, was still closed. But when I put my hand against it, I felt pressure from the other side. Not water flowing. Static pressure. Something was pressing against the gate from inside the pipe. I pushed against it experimentally and felt resistance, not the weight of the gate itself, but hydraulic back pressure, as if the pipe behind it was full. That pipe connected to the pump station's discharge system. The discharge system connected to the pumps. The pumps sat above the collection basin. If there was pressure in the discharge pipe, it meant something was pushing water up through the system, from the basin, through the pumps, and into the discharge line. Against gravity. Without any motor, we could account for turning. I told the others what I'd felt. Nobody suggested I was wrong. We drove back in near silence again, but this time the silence had a different texture. It wasn't confusion anymore. It was the particular quiet of people who are beginning to understand something they cannot yet say. That evening, Vic made a decision that elevated the situation beyond our district. He filed a formal engineering incident report with the cooperative's general manager and recommended that the Hensley city government be contacted regarding the structural and hydrological status of Pump Station 14. The report included Howe's thermal data, Corinne's amperage readings, the hydrophone recordings, and my field notes. The cooperative's general manager forwarded the report to Hensley's city engineer the following morning. The city engineer was a woman named Rhonda Cahill. She called Vic that afternoon, and Vic put her on speaker with me and Corinne in the room. Rhonda was professional and direct. She said she'd read the report. She'd pulled the city's records on the pump station decommissioning program, and she had two immediate responses. First, the city had no knowledge of any subsurface equipment below the station's collection basin. The as-built drawings on file matched what I'd already found: building, basin, intake piping. Nothing deeper. Second, the city had no record of Arlo Suttner's 1979 depth measurement showing the basin at 31 feet. The inspection report from that year was in the file, but the depth entry was blank. Either it had never been recorded, or it had been removed. Rhonda said she was going to authorize an internal inspection of the pump station. The city still owned the building and the land. She would arrange for a locksmith to open the steel door, and she wanted a structural engineer present to evaluate the building's condition before anyone entered. She asked if the cooperative would send a representative. Vic said he'd send me and Corinne. The inspection was scheduled for the following Monday, 4 days away. During those 4 days, I monitored the load data every morning and every night. The pattern had changed. The 9-kilowatt nighttime draw was still appearing between 11 and 4, stepping on in 3 stages as before. But the daytime residual was no longer holding at 1.4 kilowatts. It was climbing. Tuesday, 1.4. Wednesday, 1.9. Thursday, 2.6. Friday, 3.1. Saturday, 4.0. Sunday, 5.2. The system was drawing more power during the day. It was running longer, staying awake, pulling harder. And the nighttime peak had shifted too. On Sunday night it reached 11 kilowatts instead of 9. The steps were still clean, still sequenced, but the final stage was loading heavier than before. Whatever was cycling on at 11 p.m. needed more energy to do what it was doing. I also noticed something in the timing. When I laid out the daily load profile side by side, the 11 p.m. activation wasn't arriving at 11 anymore. It was arriving earlier each night. Monday, 11:02. Tuesday, 10:54. Wednesday, 10:48. Thursday, 10:39. Friday, 10:31. Saturday, 10:22. Sunday, 10:11. The activation was advancing by roughly 8 minutes per day. At that rate, within 2 weeks the load would be on around the clock. No more cycling, no more rest periods. Continuous draw. Monday morning, I met Corinne at the co-op yard, and we drove to the site together. Rhonda Cahill was already there with the locksmith, a heavy, quiet man named Terrence, who worked for a security company out of Jefferson City, and a structural engineer from a Hensley firm named Wade Poole. Wade was young, maybe 30, and clearly uncomfortable with the setting. He kept looking at the discharge pipe seepage, which had spread further. The wet oval was now 25 feet across, and in the center, where the water was deepest, I could see it steaming faintly in the morning cold. Terrence cut the original lock and opened the steel door. The air that came out was warm and wet and carried that deep mineral smell, limestone and iron and something else underneath. Something organic that I couldn't name. Not decay, more like silt, like the breath of a deep river. The interior of Pump Station 14 was a single room, dominated by the 2 pump assemblies that rose from the floor like iron sentinels. The pumps were vertical turbine units, each about 4 feet in diameter at the discharge head, mounted on concrete pedestals above circular openings in the floor. The openings led down into the collection basin below. The motor control center, a tall gray electrical cabinet, stood against the east wall, its door hanging open, the interior stripped of contactors and breakers. Gerald Wynn's 1987 decommissioning had been thorough on the electrical side. The panel was gutted, but the pumps themselves were still installed. The motors had been removed. The mounting bolts were empty, and the shaft couplings were bare, but the pump columns, the impellers, and the discharge piping were all still in place, descending down through the floor penetrations into the basin below. I walked over to the nearest pump pedestal and looked down the shaft opening. I couldn't see the bottom. The shaft dropped into darkness, and the air rising from it was warmer than the room. Notably warmer, maybe 95 degrees. There was moisture condensing on the inside of the shaft walls, running in slow trails down into the black. Wade Poole checked the structural condition of the floor slab and pronounced it sound. The concrete was intact, the rebar wasn't exposed, and the pedestal mounts were solid. Then he looked down the shaft opening and asked if anyone had a flashlight. Corinne gave him hers. He aimed it down the shaft and held it there for about 10 seconds. The beam caught water. There was water in the collection basin, not at the bottom, but high. Wade estimated the surface was about 8 feet below the floor. The basin, which should have been empty and dry for 37 years, was more than half full of dark, warm water that reflected the flashlight beam with a flat, mineral-clouded surface. Wade pulled back from the opening and said he wanted to measure the water depth. He had a laser distance meter in his kit. He aimed it straight down through the shaft opening and triggered the measurement. The laser bounced off the water surface and returned a reading of 7.8 feet to the waterline. Then Wade switched the instrument to its secondary mode, which measures depth by calculating the distance to a submerged reflective surface, essentially using the water's transparency to find the bottom. The meter returned an error. No bottom detected. Wade tried again. Error. He adjusted the settings and tried a third time. The instrument displayed a reading and then immediately flagged it as outside reliable range. The number it displayed was 194 feet. Wade stared at the screen. He turned to Rhonda and said, very quietly, that his instrument was rated for a maximum depth measurement of 200 feet in clear water. The reading was near the limit of the device and was flagged as unreliable. But if it was even approximately correct, the basin beneath this pump station, a basin that was designed to be 20 feet deep, extended nearly 200 feet below the building's foundation. Rhonda Cahill did not respond immediately. She walked to the second pump opening and looked down at herself, using her phone light. Then she stepped back and asked Wade to repeat the measurement at the second shaft. He did. The same error, the same flagged reading. 194 feet. Consistent. I was standing near the motor control center while this was happening, looking at the gutted panel, and I noticed something I'd missed at first glance. The panel's main feed conduit, the one that ran up through the wall to the weatherhead outside, was empty, just as I'd confirmed from the exterior. Gerald Wynne had pulled all the conductors, but there was a second conduit leaving the bottom of the panel, running down through the floor slab. A 2-inch rigid steel conduit, sealed at the panel end with a compression fitting, disappearing into the concrete. This conduit wasn't on any drawing I'd seen. It wasn't part of the standard pump station design that Pete Olvera had described. And unlike the main feed conduit, it hadn't been cut or stripped. The compression fitting was intact. Whatever wiring ran through this conduit was still in place, still connected to something below the floor. I pointed it out to Corinne. She knelt down and put her clamp meter around the conduit where it emerged from the floor. Even through the steel jacket, even without direct contact with the conductors inside, her meter picked up a magnetic field consistent with current flow. She looked at the reading and then looked at me. 6 amps, she said. Steady. 6 amps through a conduit that no drawing showed, feeding something below the floor slab, in a building whose electrical service had been completely severed 37 years ago. The current was real, it was substantial, and it was flowing downward into the basin, or into whatever the basin had become. Rhonda Cahill closed the inspection at that point. She sealed the building, installed a new padlock, and told all of us that she would be contacting the Army Corps of Engineers and the Missouri Department of Natural Resources before any further entry. She said this calmly, but I noticed she did not go near either of the shaft openings again, and when she walked back to her car she moved quickly, with the controlled haste of a person who wants to be seen as unhurried, but who is fighting every impulse to run. Over the next week, bureaucracy moved at its usual pace, which meant nothing happened officially. Rhonda sent letters. The Corps acknowledged receipt. DNR assigned a case number. Nobody came to look. Meanwhile, the data continued to change. The nighttime load peak reached 14 kilowatts by Wednesday. The daytime residual hit 7. The activation time advanced to 8:40 p.m., and the Calvary substation operator reported something new on Thursday morning. Feeder 7's voltage profile was fluctuating, not dropping fluctuating. Tiny oscillations less than half a volt, occurring in a rhythmic pattern that matched the pulse rate Howe had recorded on the hydrophone 2 weeks earlier. The pump station's rhythm was now measurable on the electrical grid itself, propagating upstream from the dead lateral onto the main feeder, reaching the substation bus. Whatever was happening beneath Station 14 was no longer contained to the building. It was in the wires, in our infrastructure, using the same grid we maintained to push its signature outward, mile by mile, toward every other load connected to that feeder. I drove out to the site alone on Friday evening, against my better judgment and against Vic's explicit instruction to stay away until the agencies responded. I parked on River Road at dusk and walked in along the access drive. The seepage had reached the drive itself. I was walking through standing water for the last 50 feet. It was warm around my boots. The air smelled like deep wells and river clay, and that unnamed organic undertone. Stronger now, thick enough that I could taste it. The building was locked. Rhonda's padlock was in place. I put my hand on the steel door, and the vibration was immediate and strong, not subtle anymore. Not the faint 60 hertz hum I'd felt 3 weeks ago. This was a deep mechanical shudder, rhythmic, the cadence of something large cycling in the earth below me. I could feel it through my boots. Standing on the soil beside Pump Station 14 was like standing on the deck of a ship with the engines running far below. I walked to the discharge pipe. The flapgate had moved. It wasn't open, but it was no longer flush. It had been pushed outward by about 2 inches, and a steady trickle of water was flowing around its edges, running down the concrete apron and into the grass. The water was warm, cloudy, and it moved with a faint pulsation that matched the rhythm in the ground. Pulse, pause, pulse, pause. The discharge system was pressurizing and depressurizing in a slow, regular cycle, like breathing. I put my non-contact voltage detector near the flapgate's hinge. It alarmed. There was voltage on the steel gate, on a pipe that connected to pumps that connected to a basin that extended almost 200 feet into the earth. The electrical potential was on the infrastructure itself, the metal, the water, the concrete. The building wasn't just drawing power from the grid. It was becoming the grid, incorporating itself into the electrical topology of the region, one component at a time. I left. I drove home. I sat in my living room and watched the load management data on my laptop until midnight. The 9-kilowatt draw, which was now 16 kilowatts and climbing, activated at 8:12 p.m. that night. It stepped on in 4 stages instead of 3. The new stage came first, a half-kilowatt flicker, almost tentative, that held for 2 full minutes before the familiar 2-kilowatt jump followed. The sequence had gained a new step. The startup procedure was getting longer, more complex. I thought about what that meant in the language I understood, the language of electrical systems. When a control sequence adds steps, it means new equipment has been connected. New loads, new components that need to be energized in the proper order. The system beneath Station 14 was not just waking up. It was growing. Monday morning, Corinne met me at the office with a printout I hadn't asked for. She'd spent the weekend pulling load data from every other feeder in the Calvary substation service territory. She'd found 2 more anomalous draws. One on Feeder 3, which served the north side of Hensley, appearing as a 2.1 kilowatt residual on a lateral tap coded to a legacy municipal account. Hensley Municipal Pump Station 9, disconnected in 1987. The other on Feeder 11, East Hensley, A 1.7 kilowatt draw on a lateral coded to pump station 6, disconnected the same year. 3 stations, 3 supposedly dead facilities, drawing power from 3 different feeders. The loads on stations 9 and 6 were small nascent, Corinne called them, but their harmonic profiles were identical to what station 14 had looked like 3 weeks ago. Clean 60 Hz sinusoids, staged activation, nighttime onset. Station 14 wasn't alone. It was first, and the others were following the same sequence, weeks behind, activating one by one along the Osage River bottoms like signal fires answering each other across a dark ridgeline. I asked Corinne how many of the original 16 stations were within the cooperative service territory. She checked the old records. All 16 laterals were still on the books, dead taps on various feeders, legacy municipal codes, all showing disconnection dates in 1987. She said she could write a script to flag any anomalous load appearing on any of those 16 lateral codes. By Wednesday, she had the script running. It flagged Station 9 and Station 6, which we already knew about. It also flagged Station 2, a 0.4 kilowatt draw, barely above the noise floor, appearing on a lateral that hadn't carried current in 37 years. Onset time, 11:58 p.m. 4 stations, waking in sequence, drawing power from a grid that couldn't explain how they were connected to it. Each one sitting above a collection basin that might, like Station 14's, extend far deeper than anyone had measured. Each one built to respond to rising water. The Corps of Engineers finally sent someone on Thursday, a geotechnical specialist named Ray Duarte, who drove down from the Kansas City district office. Rhonda Cahill met him at the site. I wasn't officially invited, but Vic sent me along to provide electrical context. Corinne came because Corinne always comes. Ray Duarte was a careful man who spoke like someone accustomed to writing reports that would be read by lawyers. He inspected the exterior seepage, now covering an area 30 feet across and deep enough in the center to submerge the grass entirely. He measured the water temperature at 93 degrees. He took 3 samples. He looked at the thermal camera data Howe had collected and nodded slowly without comment. Rhonda opened the building for him. Ray entered alone and spent 20 minutes inside. When he came out, he was carrying his own laser distance meter and wearing an expression that I recognized. It was the same look Howe had worn when he'd felt the warm water 3 weeks earlier. The look of a technical professional whose instruments have just told him something that his training insists is impossible. He asked Rhonda to close and lock the building. Then he stood in the wet grass and told us what he'd found. The water level in the basin had risen. When Wade Poole had measured it 10 days earlier, the surface was 7.8 feet below the floor. Ray's measurement put it at 5.1 feet. The water had risen nearly 3 feet in 10 days. At that rate, it would reach the floor slab in less than 3 weeks. He also said that he dropped a weighted thermometer on a cable into the water and lowered it as far as the shaft opening would allow, about 12 feet below the surface. The temperature at 12 feet of depth was 104 degrees. The water was getting warmer the deeper it went. And he said one more thing. He said that while he was leaning over the shaft opening, taking readings, he had heard something coming up from the water. A sound. Not the rhythmic pumping that Howe's hydrophone had captured, something else. Higher pitched, intermittent. He described it as a series of tones, almost musical, rising and falling in a pattern that repeated every 30 to 40 seconds. Ray Duarte said it sounded like a signal, like something was communicating through the water column. He recommended immediate installation of water level monitoring equipment in the basin, a full geotechnical survey of the subsurface conditions beneath the building. And this was the part that made Rhonda go still notification of all 16 pump station sites along the Osage corridor. Because if the same subsurface water source was feeding all of them through the original drainage network, every basin in the system could be filling simultaneously. That was 17 days ago. I'm recording this on a Wednesday evening. Here's what has happened since. The Corps authorized emergency water level sensors in Station 14's basin. The data comes to a monitoring dashboard that Rhonda shared with Vic, who shared it with me. The water is rising at a steady rate of 3.4 inches per day. As of this morning, the surface is 1.9 feet below the floor slab. At current rate, water will begin flowing through the shaft openings and onto the pump station floor within 7 days. Corinne's monitoring script has flagged 11 of the 16 pump stations. 11 dead facilities drawing power from the grid through connections that don't physically exist. The loads are staggered. Station 14 is the largest at 22 kilowatts and climbing, and the newest activations are barely registering, but they are all following the same pattern. Staged onset, clean harmonics, nighttime activation that creeps earlier each day. The total parasitic draw across all 11 stations is now 61 kilowatts. It is projected to exceed 100 within 2 weeks. The Calvary substation's capacity is not threatened. The draw is small relative to the system, but the voltage oscillations on feeder 7 have spread to feeders 3, 11, and 5. The rhythm is in the grid. Every customer on those feeders is receiving power that pulses faintly at a frequency that matches whatever is cycling beneath the river bottoms. The seepage at Station 14 has reached River Road. There is warm water running across the pavement in a slow sheet, draining into the road ditch and flowing north toward Hensley proper. The County Highway Department put up a water on road sign. They don't know where it's coming from. Hao Chen returned to the site last week with a more sensitive hydrophone array and a geophysicist from the university in Rolla. They recorded for 6 hours. The rhythmic pumping sound is louder now. Hao said you can hear it with your bare ear if you stand on the wet ground and hold still. The geophysicist ran a seismic refraction survey and identified what he called a velocity anomaly in the subsurface zone, beginning at approximately 200 feet below grade and extending to an indeterminate depth, where seismic waves travel faster than they should through any known geological formation in the Osage River Basin. He said the anomaly is laterally extensive. It isn't directly beneath Station 14, it's beneath all of them. A continuous structure running along the river, paralleling the levee, at a depth that no one has ever surveyed because no one had a reason to. The tonal signal Ray Duarte heard has been recorded and analyzed. It repeats on a 42-second cycle. The frequency content is between 180 and 460 Hz, well within the range of human hearing, and also within the operational frequency range of the electromagnetic flow sensors used in the original pump station control systems. The signal is not random. It carries a modulated pattern that the geophysicist described, reluctantly, as structured. He would not say what he thought was producing it. Vic Paletti resigned from the cooperative on Friday. He cited personal reasons. In his exit conversation with me, just the two of us, in the parking lot, his truck already packed, he said he'd run the numbers on the electrical load growth curve. If the draw from all 16 stations continues to increase at its current rate, and if the 5 stations that haven't activated yet come online on the trajectory the first 11 suggest, then within approximately 90 days the combined parasitic load will exceed the Calvary substation's nighttime base capacity. The system beneath the river will be consuming more power than the city of Hensley uses while it sleeps. He said he didn't know what that meant. He said he didn't think anyone did. He said he had looked at the original 1961 federal grant that funded the pump station construction, trying to understand why 16 stations were built along a stretch of river that hydrology reports from the era said needed, at most, 4. He found the grant application in the National Archives digital catalog. The application was submitted not by the city of Hensley, but by an agency called the Federal Subterranean Water Commission, which he could find no other record of. The grant's stated purpose was not flood mitigation. It was monitoring and management of upward hydraulic migration from deep subsurface sources in the central Missouri Osage corridor. Upward hydraulic migration, water moving up from deep below. The pump stations were never built to push stormwater over the levee. They were built to push something back down. And in 1987, the city of Hensley, which may never have understood what the stations actually did, turned them all off. I am still employed by the cooperative. Corinne is still monitoring the load data. Rhonda Cahill is still waiting for the Corps to mobilize a full investigation team, which has been delayed twice for reasons no one will specify. The water at Station 14 is now 11 inches below the floor. The discharge flap gate on the levee face is open by 6 inches, and warm water is flowing continuously into the river, steaming where it meets the cold current. Last night, the activation time for Station 14's load crossed into late afternoon. The system ran for 19 hours straight. During the peak draw, Corinne recorded a series of voltage transients propagating outward from the lateral, the same kind Howe first saw weeks ago. The brief pulses that looked like a generator sinking to the grid. But they weren't brief anymore. They lasted 4 to 5 seconds each. And they carried a modulated signal embedded in the waveform, a pattern that, when Corinne isolated it and played it through an audio converter, matched the tonal sequence rising from the water in the basin. The signal is in the grid, in the wires, in every transformer and service drop and breaker panel connected to the Calvary substation's distribution system. Every house in Hensley that draws power from those feeders is receiving it, not as sound, not as light, as electricity, woven into the 60 hertz current that runs their clocks and charges their phones and hums in their walls while they sleep. I don't know what it's saying. I don't know if saying is the right word. But I know it's structured. I know it's getting louder. And I know that somewhere beneath the Osage River bottoms, in a geological formation that isn't on any survey, and at a depth no instrument has reached, something is pushing warm water upward through a system of basins that were built to contain it. The pumps were the barrier. The stations were the wall. 16 mechanical hands holding the water down, keeping the pressure managed, keeping whatever rises in that corridor from reaching the surface. For 26 years they ran. For 37 years they've been silent. And now the thing they were holding is reaching up through the infrastructure that was built to stop it, the basins, the pipes, the wiring, the grid itself. And it's found that the path is open. Every disconnect cut, every breaker locked out, every wire pulled, every door sealed. They didn't decommission a pump station. They opened a valve, and the water is almost at the floor.